Welcome to College Algebra. In this lecture video, we're going to continue talking about section 4.3. This video, we're going to begin to mention something called the bounds of zeros. The bounds of the zeros. So, the whole idea of a bound of zero is basically provides, the upper and lower bound of zero provides a guidance that helps to reduce the number of the potential zeros that we mentioned in the previous video. You know, the P over Q thing? It reduced the number of potential zeros that must be tested by trial and error. So this is kind of very strange idea today, because today we use graphing calculator to do a lot of legworks for us. So back in the day, before the graphing calculator was ever invented, it makes sense we have talking about the rational zero theorem where we got a list of P over Q. It makes sense that we have that scar rule assigned that kind of give us a guide on how many positive and negative real zero we can have. So this is one of those things. Same idea, okay? Same idea. You know, give us a guide on, you know, which one of those rational zero I would need to test, okay? Because it can be a lot of numbers we have to test. So basically, last time when we did the P over Q thing, so this particular example, okay, without a graphing calculator, which one of these are my real zero? So what people do back in the day is use synthetic division to do every single one of these. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There are 16. Okay, you can't. It's just not practical to test all 16 of them. Okay, so one way to kind of help reduce the potential, okay, number of zero that you try it out is by upper and lower bound. Okay, so let my f of x to be a polynomial with real coefficients, a positive leading coefficient, and a degree that is greater than or equal to 1. A positive leading coefficient, see, that's another thing gotta watch out for. There need to be a positive leading coefficient. Let a to be a negative number and b be a positive number. Then no real zero of the function is going to be larger than b. And we say b is an upper bound of the zeros of my function. Okay? If the last row of the synthetic division contains no negative numbers. That is to say, b is an upper bound of the zero if the quotient and the remainder have no negative coefficients. Okay, so there's going to be no real zero bigger than this one particular integer. Alright, no real zeros for my function is smaller than a, and we say a is a lower bound of the zeros if the last row in the synthetic division has entries that alternate in signs. Okay, alternating sign means positive, negative, or positive. Zero can be counted as either positive or negative. So I will attempt not to use a calculator to do this. Okay, this is a little bit of work because we actually need to try it out, certain things. Use the synthetic division to identify integer bound of the real zero. Find the least upper bound and the greatest lower bound. Alright, so let's give this a try. Okay, let's give this a try. The easiest way is find the smallest integer. Start out with the smallest integer. Okay, so I'm gonna do the positive one first. I'm gonna find this b first. So I'm gonna start out with 1. So what I'm gonna do is, since I gotta try a lot of these, I'm gonna take an image of this. 1, negative 3, no missing terms. 6, negative 12, and positive 8. Alright, I'm gonna take a picture of this. So I'll use it again in a minute. Ooh. This is a copy. Okay. All right, I'm gonna start with 1. So I have not even done my P over Q thing. Maybe I should have done that. P is 8, Q is 1. So in my mind, I'm thinking P, what times what is 8? 1 times 8, 2 times 4. Over Q, Q is just 1 times 1, which is 1. Alright, so 1 over 1, 2 over 1, 4 over 1, 8 over 1 are the positives. So that's why I started with 1, because 1 over 1 is 1. Alright, bring down the 1, multiply, which is 1. If I add them up, that's a negative 2 right here. So remember now, if the last row of the syntactic division contain no negative, so here's a negative, 1 doesn't work. It's not my what? It's not my, what's the wording they use? It's not my least upper bound. Okay. Least upper bound simply referring to I can have bigger number than the smallest one that will do it for me. Alright, let's try with 2. Bring down the 1. 2 times 1 is 2. Syntactic division, if I add, that's a negative 1. So 2 is not my least upper bound either. Cannot have a negative sign here. Try with 3. Now remember now, I have no idea what the real 0 is, okay? So I'm just looking at these and think of a number. Just try out all those integers up to 8, because I cannot go higher than 8. 8 is supposed to be the largest rational integer I have. 3 times 1 is 3. If I add them up, that's a 0. Can't have 0 here. Try with 4. Check it out. Bring down the 1. 4 times 1 is 4. If I add them here, it's a positive 1. 4 times 1 is 4. Add them up is 10. See, it's all positive so far. 4 times 10 is 40. If I add them up, I think it's 28, I believe. Still positive. 4 times 28, add them up, still positive. So, this one will be my answer. Okay, that's the largest one. Okay, that's the largest one. Now, I didn't finish none of these. You know, if I will have finished, I will probably see which, I probably can tell which one of these numbers I tried is my 0. Okay, so since it's going to be a positive number, and as a remainder, 4 will be my least upper bound. So that means anything higher than 4. If I try with 5 here, these should still be positive as well. That's what we call 4 is the least upper bound. Now let's try with negatives. Okay, try with negative, because these are the positive 1, positive 2, positive 4, positive 8. I can also have the negative 1, negative 2, negative 4, negative 8. So if I try with negative 1 first, bring it down. The rule for the negative says the last row gotta have entry that alternate in sign. 0 can be counted as either positive or negative. If I multiply, that's a negative 1. If I add them up, that's negative 4. So far so good, because I'm alternating sign on this last row. Negative 1 times negative 4 is positive 4. That's a 10. This is negative 10. Add them up is negative 22. So I'm still alternating signs. Negative 1 times negative 22 is positive 22. If I add them up, that's a 30. So since I'm alternating signs, then this is going to be my greatest lower bound. Okay, greatest lower bound. This is the greatest lower bound. That's the least upper bound. Alright, so this is what I'm going to do, okay? I'm going to use a calculator still. Let's see what my zeros actually is, okay? The real 0. The rational 0, to be more precise. Minus 12x plus 8. So I actually have no negative real zeros. Okay, both are positive here. Okay. So exactly the way it is. One zero, 2 0. So 3 give me the 0 right there. That's why I didn't use it. When I add them up, gotta have all positive signs. So that's why I choose 4. Okay. So I will test anything under 4. Without a calculator, I will actually test anything under 4, and I will come find out 1 and 2. When I test it, the remainder will be what? Will be 0. So this is just a quick way of finding your least upper bound, and then go back underneath the least upper bound and then finish off the problem. Then I will know which one are my zeros. Well, let's try again. Okay, 15. This is 1. So that's 1 times 15. 3 times 5. Oh. So I can potentially go all the way up to 15. Alright, let's do the same thing again. 1, negative 5, negative 3, 15. Remember now, I'm doing this problem pretending I don't have a graphing calculator. Okay. The ultimate way to find zeros, we will use calculator to help us out. Oops, sorry, Alright, let's see. I'm gonna try with 1 again. Alright, remember the last row. Okay, the last row for the greatest lower bound, it's the least upper bound. Last row contain no negative. Okay, 1 times 1 is 1. Add them up. That's negative 4. That's a negative right there. Nope. Try with 2. Bring it down. That's 2. Add them up. Negative 3. Nope. Okay, let's try another one. 1, 2, 3. Try with 3. Bring it down. That's a 3. Add them up. That's negative 2. So you can see the pattern right here. Okay, 4 may not work because that would right away give me a negative sign, I believe. Right. So try with 5. 5 will probably be 0 right there. Yep. So I will use 6. So I can quickly go through this. Find out what 6, add them up, will be positive 1. Keep on going. Make sure everything is no negative signs. That's 6 times 1 is 6. Add them up is 3. And this multiply is 18. Add them up is still positive. So 6 can be my, what did they call it again? Mr. Chin not good with English words. Least upper bound. So I can choose 6 to be my least upper bound. Okay. Now, when you put this in the homework and then say 6 is wrong, you know what I'm saying? And the answer shows 5, that means they are counting the 0. But I don't think so, because it doesn't say anything about zeros here. It's just saying contain no negative signs. Because 0 can be negative or positive. Alright, so 6 is my least upper bound. Let's see what is my greatest lower bound. So I'm going to try with negative 1. Remember, I got to alternating my signs here. That's negative 1, so that's a negative 6. If I multiply here, it's a positive 6. Add them up, it's a 3. That's negative 3. Add them up. That's a positive right there. So there's not alternating signs. So nope. Try with negative 2. Alright, that's negative 2. That's negative 7. That's positive 14. So that's what, 11? Negative 2 times 11, negative 22. So that's positive 7. So I'm alternating signs. So negative 2 got to be my greatest lower bound. Okay? So what that means is I will try, okay, I can try
I can try for the negative zeros. I can try anything, start with -1, anything bigger than this. Alright, 6 is the least upper bound, so I will try anything smaller than 6. Okay, so that's the reason why, if you notice, these problems on the homework are the second steps of after the Dascal rule of sign. So when we do Dascal rule of sign, notice how many sign changes for the positive negative does affect what we do here at the same time. So the two is kind of go hand in hand. Alright, now in the next lecture video we will wrap it up 4.3, which will talk about the ultimate way to find the zeros of a polynomial function. Alright, thank you for watching this particular video on the bounds of zero.